Okay, good afternoon, everyone. Let's allow us a couple of minutes, maybe.
Yeah.
Till we wait for a few more people to join.
It says I've been muted.
Yeah, sorry, I had to mute everyone, but I was going to unmute you.
Okay. Go ahead.
Yeah, thank you.
Do what you have to do. But it's time to start, I think.
Yeah. So I'm going to kick off. Thank you, everyone, for joining to the technical meeting number 10. Today we have David Hewlett running the webinar. He's right now in the USA. He's in Los Angeles, I guess, right now.
Correct.
Yeah. So before starting, I would like to just provide some a few housekeeping items. Everyone, please mute yourselves during the presentation. All the questions will be attended at the end of the presentation. We have a long presentation to go, so we're going to try to put them all at the end. The presentation will be available in our YouTube channel at the end of this week, and we're going to share as well the slides. And the certificate of attendance will be also shared only for AACE members. And well, I think I'm going to hand it over to David so that we can start. Welcome, David, and thank you for accepting being the presenter today.
Thank you, Frank. I appreciate it. Thank you for inviting me. Good evening or morning, wherever you are. We're in the evening here in Los Angeles. I'm going to talk about the journey map to a more mature schedule risk analysis process. I'm David Hewlett. I run Hewlett and Associates, consulting firm here in Los Angeles with a few associates, and we do project cost and schedule risk analysis as well as training in the subject. We do consulting and all over the world and for government as well as commercial clients. So what I'd like to do, this is a paper that was actually published in the Cost Engineering Journal of AACE a while back, and I would like to go through it with you. I've updated several things in it. Okay, no, I can't do it again. What the heck? There we go. Okay. What is a journey map? Well, this is a term that was developed by a fellow who had got me to do some consulting on risk analysis maturity for Petronas in Kuala Lumpur, Malaysia, and he used the term, and I thought that's such a really very good term. So we have used that for the title of this, and I want to show you what my journey map is made up of. This is a schedule risk analysis maturity model. And it goes from all of a sudden level 0, which is unaware of cost or schedule risk, all the way up to level 5, advanced integration of cost and schedule risk analysis. And one of the things is to find out how mature your organization is today. And we did a lot of interviews of a lot of the operating divisions of Petronas, and we came up with some findings of that. And then the question was, where do you want your organization to be tomorrow? We found that they were sort of in the lower end of this schedule, and then in about a month they asked me, please would you perform a level 5 advanced integrated cost and schedule risk analysis on an offshore drilling rig, offshore production platform? And oh yes, you want to jump right to the integrated, the most advanced version of this. So that's what we did, and we did a lot of those, number of those for Petronas. Okay, so I want to focus on levels 3, 4, and 5 because the distinction between level 3 and level 4 and level 5 is important, and that's where we want to focus. But I want to mention that level 3 is essentially called range estimating or activity ranging, and it was a title of a recommended practice 41R08 range estimating. And just today, it came out from the headquarters of AACE that this has been released for public comment before actually publishing, and not 47R08, but 47R08, a new version called Understanding Estimate Ranging. And in Understanding Estimate Ranging, it says about 41R08, this RP is being withdrawn as we can no longer recommend range estimating as a specific estimate ranging practice in support of risk analysis and contingency determination. So when it is put down in this paper as a source, it is as a source canceled in 2021. Well, I already had this presentation done, and basically I'm going to tell you about my views on level 3. I'm one of the contributors to this new recommended practice, so I'm very much in sympathy and in sync with that particular approach. Okay, so but level 3 does recognize that the project schedule success is affected by uncertainty of the estimated durations, and that it can be analyzed statistically by applying Monte Carlo simulation, MCS, to a schedule of a project using specialized Monte Carlo simulation software. So it's a lot better than just qualitative analysis at level 2. So we don't want to slam it, except that by now it is no longer acceptable to AACE. One of the reasons is that variability of activity duration is represented by applying probability distributions, usually the low, most likely, and high values, directly on the activity durations. So you get somebody, you say you got 50 activities, let's take the top 30 of them. What's your expectation of the range of how long and how short they will be? And ultimately they'll say, okay, give me a 20% and a minus 10%, or here what I think about how long those activities would be. And guess what? It does not represent or recognize or require identifiable risks or distinguish uncertainty from risks when developing those ranges. Matter of fact, it's not really risk analysis at all. It's a range analysis. Now that doesn't mean it's unuseful to everybody. For instance, it produces histograms and cumulative distributions from the Monte Carlo simulation, giving probability of finish date and on time and estimates of contingency of schedule and of cost if you use cost. And one of the things it does do, and we'll mention this again, is it gives you the opportunity to say which activities are more likely to be on the critical path once risk is assumed, which might be new information to the project manager because he or she doesn't know anything beyond the critical path shown in Primavera P6, for instance. It's remember one of my friends said, I know what the critical path is. It's the one in red in the scheduling software. And I said, well, wait a minute, with the risk, it may not be the one that is most likely to drive the project. And so sometimes that is new information at level 3. But again, that's not risk. Those are activities, those are not risks. So, so the capabilities needed, you need to understand, assess the schedule against which to plan this Monte Carlo simulation. We'll talk a little bit more about that when we talk about level 4, and then the Monte Carlo simulation software, which we can do. I used to use this method, level 3. That was before we identified and got comfortable with what I'm going to show you in level 4 and level 5. Okay, the benefits are that it avoids having to guess at the impact of the finish date. In qualitative risk analysis, somebody says, here's the risk, and if this happens, it's going to have a level 3 impact on the finish date, or level 5, or level 1. And by the way, its probability is such and such a level as well. That way, for the risk register, people have to be trying to think about whether the risk, if it occurs on the critical path, and what's the impact of that going to be. And they have to know something about if they do it right, they have to know something about the logic of the schedule. Well, they don't, and so they don't do it right. And so we are able to do that at level 3. And it provides some of these methods some of these results that I talked about. But the weakness and the why 41R08 is now withdrawn, or will be withdrawn as according whenever the public comment period is done with this. Level 3 does not use individual risks, and because it doesn't use individual risks to drive the Monte Carlo simulation, it cannot identify which risks cause the fluctuation in the Monte Carlo simulation. And if this is a risk analysis, that seems to me to be one of the first things you should be able to do. And in fact, that is one of the ideas about risk going that's in the AACE methodology on what is actually required for the software. And it says essentially you got to start with the risks. Well, level 3 does not do that. Level 3 is found in a lot of organizations, a lot of agencies, a lot of guides, and even some textbooks. And as I say, up until about 12 years ago, that's what I did. But it don't, just because it's in textbooks does not mean it's a good idea. Level 3 does not handle the probability that a risk will or will not occur. If you're putting those ranges directly on the activities, you're putting the ranges on the activities as if they were 100% likely to occur. And you know that one of the characteristics, one of the fundamental characteristics about risk is the probability that they will occur with some impact. And the probability, if you're putting the ranges directly on the activities and they all happen all the time, with random selection, of course, of the duration, that is a situation where you can't really answer the mail about which risks are important. And you cannot assess the full impact of risks that affect multiple activities. So if you identify a risk and it affects 100 activities or 3 activities or 1,000 activities, that the number of activities it affects may very well make it a very important risk or a very unimportant risk with the same parameters, with the same probability and impact parameters. So but because you're looking at each individual activity in level 3 individually and getting a range of the duration of that activity, you don't know whether the risks that are causing that range are affecting the next activity or the next activity or 100 activities. And I've had risks affecting 1,000 activities. So, this is a very important point. Let's take a risk that has, say, duration that has 3 risks assigned to it. How do you construct a probability distribution with a low, most likely, and high for that activity from the interaction of those 3 risks, some of which are unlikely to happen or likely to happen depending upon their probability? And that is not easy. It can be done. I've done it, but only as an illustration, because that can't be done just by waving your hand and saying something. By the way, the last thing is it requires specification of correlation coefficients between activity durations. That is, if this activity is longer, that activity is also longer. If this activity is shorter, that activity is also shorter, usually positive correlation. You have to specify correlation. So somebody says, well, how do we do that? Well, low correlation is maybe 25%, and moderate is maybe 50%, and high is maybe 75%. That doesn't tell me how the correlation is between activity 5 and activity 6. And we'll show you how that works using the methods available to us at level 4 and level 5. Okay. So let's go to level 4. Oh, and by the way, those are the kinds of things that AACE is concerned about when it has decided to cancel the previous recommended practice 41R08 range estimating and substituting it the same number, but understanding estimate ranging, which obviously is going to be talking about a lot of this. So let's look at level 4. Now at level 4, we start with quantitative and modern quantitative schedule risk analysis. Okay, so the first thing is we do we identify the risks to the model that we're going to simulate. We can identify the risks to the model. Now, these could come from the risk register. I'm going to talk to you a little bit about risk data collection in a while, but the risk can be distinguished between uncertainty and identified project-specific risks. In 2019, I got through the tech board in AACE, a new definition of uncertainty that was added to the two definitions that were already there for the term uncertainty. And it has to do with estimating error, estimating bias, and inherent variability of things. And I'll return to that. But I guess what I'm saying is uncertainty when we're doing Monte Carlo simulation is really background noise that cannot be reduced in the space of one particular project. Identifiable project-specific risks, on the other hand, are specific to the project. They have a probability and an impact, and they affect certain activities. I also include systemic risk in there as well, and they can be mitigated. And in fact, one of the crucial things about level 4 and level 5 is you can mitigate risks by first prioritizing them, and we'll talk about that. So we want to collect data on identified risks, probability, and impact. Well, first of all, we have to identify the risks, and I start with the risk register. I'll come back to the methodology in a moment. Then we apply the risk to all the activities they affect. And so you might have a risk that affects all piping activities in a refinery, or all engineering activities in an aerospace project, or all procurement activities, or things having to do with the soil and the land. Those areas might very well have a number of risks that are common to all of those activities. And so we have to identify which risks are involved with all those activities. Then you apply risk to all the activities that they affect, and the duration of those activities become affected by multiple risks if there are multiple risks assigned during the Monte Carlo simulation. In Monte Carlo simulation, each risk that's assigned gets a randomly selected probability of happening, and if it happens, a randomly selected probability multiplier effect. So that's what we do. We often use a summary schedule for the risk analysis. Right now, I've got a 2,000 activity summary schedule. The project contractor's schedule could not be fixed. So in order to satisfy the best practices for the risk analysis, it's pretty demanding, although it's just good CPM scheduling. Okay, so the first thing to do is to do this, and this is just the schedule risk assessment guide that I have used from the United States Government Accountability Office, and there are 10 best practices. I want you to look at the best practice number 8, conducting a schedule risk analysis. Wait a minute, conducting risk analysis is part of scheduling? Well, if you think about it, if scheduling is trying to decide and trying to discover when the project is going to be finished, and also major milestones, relying on what comes out of your scheduling software, even if it's great scheduling software, you find yourself behind the 8 ball very quickly, and very likely it's a lot easier to overrun those durations than underrun those durations. If you don't collect a schedule risk analysis, you cannot really say that you know when that project is going to be finished. You can say what it is using the deterministic durations and the logic that go into the scheduling package, and follow all the rest of these best practices, but you can't really tell when it's going to finish. And that's only the first half of the job. Second half is doing the schedule risk analysis, and I like that. I think that's what we're doing here. How do you collect good quality risk data? So there's a schedule. Now we've got to do risk data. We haven't talked about software yet. In risk workshops, let's say there are 20 people in a room for a day, and the facilitator and all. Everybody's in that same risk workshop, and for a whole day. And there are a lot of people exposed to various cultural and hierarchical pressures of people to go along, to get along and agree with the boss. And a lot of people won't be able to talk, or they won't be able to talk very much, or they won't be able to say what they really want to say, because they're going to be shouted down or discussed. I remember one guy whose boss's boss took him into the corridor and said, "We don't talk about that." which meant essentially he had hit on a real sore point that disagreed with what they'd been telling the board of directors or something. And we don't talk about that. Not that it wasn't a risk, not that it wouldn't happen, not that it wasn't important, but we can't talk about it. And in fact, out of the 20 people, very few people will be able to speak very much. Now, how much burden is there on the personnel? 8 hours a day for 20 people is 160 staff hours. That's a lot. Here's what I do. I conduct confidential risk interviews where I say to them, I'm not going to tell you what anybody else said. I'm not going to tell anybody else what you said. In fact, the numbers that we use for in the analysis will be a combination of yours and everybody else's who have opined upon the probability and impact of these particular risks. Now, by the way, these just for the burden part of it, these interviews generally take about 2 hours, sometimes more, sometimes less. You have to reschedule or you get out a little early. For those 20 people, that's 40 staff hours as opposed to 160 staff hours away from their desks. Excuse me. So at that point, I say, look, this economizes on your staff's time. Come on, let's do it this way. They'll get back to their desks in 2 hours. So, okay. But you get better quality data. We always identify more risks. Risks that are not in the risk register. Risks that I like to call unknown knowns. That is, these are the risks that are sort of the elephant in the closet and we can't talk about it. On the other hand, it's very important. If you really believe that you're in a confidential interview, people pipe up and they say these things. And sometimes these are the most important risks in the analysis. And if you don't say those things, don't give them a chance. You don't want to encourage them. You don't sit across the table for 2 hours, very interested in what they have to say about risk, as opposed to 8 hours when they can barely get a word in edgewise in a workshop. Then you get some things where they're really honest about what the risks are and the probability and the impact. And we interview people from all perspectives and all that. When we consolidate the people's information on probability and impact for a particular risk, we try first to look at the averages of the individual's data about probability, optimistic, most likely, and pessimistic, using the wisdom of crowds, which says essentially if you get enough people that are somewhat knowledgeable, maybe averaging them will give you a good number. But we look for outliers. We look for people who didn't understand the methodology or were trying to bias the numbers. And sometimes I don't believe certain people. Oops, I didn't want to do that. No, I certainly didn't want to do that. Okay. I pushed the wrong button. Okay. So this is a picture of an uncertainty. Remember, uncertainty is 100% likely to happen, and you can't mitigate it during the pace of one project because, first of all, it's uncertainty in the sense that we don't know exactly what's causing it. There are many small things that may be causing it, but here's what it does have. Again, this is the revised in 2019 version, which I put in there just for us, those of us who are using Monte Carlo simulation. Estimating error. This is not saying the estimators are bad, the schedulers are bad, the planners are bad. This is saying that every single discrete number that you put in there has an error factor. And the mature ones of us understand that's not a knock on them. Estimating bias. I mean, I've seen projects where they say the schedule is for 32 months, but when we look at the bias, we think that most likely it's going to be 36 months or 40 months. That is because there's a significant pressure to be optimistic when you're developing a schedule, and inherent variability of people and organizations not being able to be relied upon to do things according to plan. If those of you who knew Six Sigma, you want to look up the definition of common cause, that's what it is. And from this point forward, I'm going to start talking about recommended practice 57R09, and that's one I did in 2011 and revised it in 2019, called Integrated Cost and Schedule Risk Analysis using Risk Drivers and Monte Carlo Simulation of a CPM Schedule. That's a mouthful, but okay. So this is the uncertainty part of that, and this just says you see the 100% is highlighted, 100% probability, and the range is 95%, 105%, and 120% for the minimum, most likely, and maximum. and its triangular distribution. I think it's most important to get the ranges right, not to worry about what's the shape of the distribution. But I'll leave that to you. The idea is that when applied to the durations, either of say all site work or all finishes, for instance, or all procurement, or all all piping, you will end up saying, okay, what are those activities? And you might say, hey, it could be as much as 5% lower. It might be 5% higher than in the schedule. It might be as worse as 120% of the schedule duration. And those numbers are applied across the board. And if they are not acting independently, then they also make the activities correlated. As I say, they can be made in reference ranges like individual parts of the schedule, or they can be assigned to the whole schedule, but they're 100% likely. By the way, the screen captures here are from Saffron Risk, which we use a lot. And that's what the screen capture is for uncertainty. Here is some actual risk drivers, and you can see in the red box there on the left that the probabilities are from 20% to 80%. I think in risk interviews that are confidential, you'll get higher probabilities than you would in a risk workshop where there's pressure to agree with the boss. But that's good. I mean, I think that's more like what the people really mean. Okay, and then there's a triangular distribution, in this case 95, 110, 125 for a particular risk number 106, which is 65% likely. And then there's an assignment of that to various other activities. This, however, is the picture of, say, risk 106. Risk 106. And this is the histogram that comes from simulating this 10,000 times. And you look at that and you say, wait a minute, I've never seen such a probability distribution, such a messed up probability distribution where there's one spike up there. What in the heck is that doing there? Usually they're smooth, aren't they? I've had people say that doesn't look like any distribution that I thought of. But if you think about it, what's in that spike is the 40% chance that this risk does not occur. If it doesn't occur, then none of this distribution applies. The 30 days is accurate, according to the fact that if this is the only risk happening and there's no uncertainty, this is just all that's happening for this one idea. There's 40% of the iterations of the 10,000 iterations in that spike, plus some extra. Actually, there's 4,500 occurrences in a 10,000 activity, 10,000 iteration schedule. And the reason for that is that even if the risk does occur, the multiplier of 100 is quite likely. It's between 90 and 110, for instance. So we'd added another 500 hits to the 4,000 that were because of the risk not happening at all. Okay, and so that you've got to become familiar with that. But once you become familiar with that, you understand, yes, this is the way it ought to be if the risk is uncertain to happen. And then we get this, which is just the application of the risk to various activities. And you see that some risks, 101 and 102, are assigned to everything, but those are the uncertainties that I've used as risks. And then the 110 and 111 on the right-hand side, 110 is a systemic risk that applies to a lot of stuff. 111 is a very general risk that applies to a lot of things as well. But the other ones apply to engineering or procurement or fabrication or drilling. Those are just the major divisions in the schedule itself. Okay, now I said there's correlation. And I said in level 3, you have to estimate correlation, and we are really bad at that. I mean, there are no really good data that will show you, excuse me, how much correlation there is between two different activity durations. But here I'm going to show how you can develop correlation using risk drivers so that you don't have to worry about guessing at what the correlation is anymore. You're going to develop it by having one risk, you see it there on the left, affecting activity 1 and activity 2, and nothing else happens. And I did that for 10,000 iterations, and I pulled out the 10,000 pairs of durations for activity 1 and activity 2, put them into Excel, and did the correlation calculator on it. And the answer was 0.99996. I figured that's like 100. And you see the picture on the right, if they're perfectly correlated, the scatter diagram with one duration on the vertical and one duration on the horizontal is a straight line. And this one shows that it's 100% likely. So that's what happens if, now that 100% likely is correct, if this is all that's happening. And it is generated during the simulation, so you don't have to worry about that. Here's the next thing that happens. I've added 2 different risks as confounders. One is one on the left that affects activity 1 and one on the right that affects activity 2. The risk probability, the one in the middle is still there, but now I've got some things that affect one but not the other. I've run that. Again, I couldn't have guessed, but it turned out that in Excel, the correlation calculator, and then over here on the right-hand side, the number in the red box shows it's 38% correlated. And I don't know how many of you guessed that. If I had covered that up and said how likely would it be, you might have guessed 50% or 80% or 10% or whatever it was. Well, now you don't have to, because I've actually developed a methodology where the correlation is generated during the Monte Carlo simulation. Good idea. This is just something that says that the risk can be entered in series or in parallel. If they're entered in series, the top one, a 1.2 factor and a 1.05 factor, they're multiplied together to get a 1.26 multiplier for that particular iteration. Now, if you can think about some of these activities with some of these fairly high probability risks occurring, and maybe you've got 6 or 7 risks affecting one activity. So in many iterations, you've got 4 or 5 risks actually happening. And all of the things are, unfortunately, I'm saying all the things are threats. So their impact is over 1. You start multiplying 4 or 5 numbers that are over 1 to the duration of an activity, you're going to find a duration that nobody will believe. It's too high. It's very much higher. And that's because you were saying that you got to mitigate the risk 1 before you can get to risk 2. So look at the next part is risks in parallel. And I got a risk 1 is 1.2 factor and risk 2 is 1.05 factor. In parallel, the software will pick the largest, which is 1.2. And you can have 5 of them that are 1.2, 1.3, 1.1, 1.0, 0.95, 1.1, etc. It'll take the largest one if they're in parallel. It'll multiply them if they're in series. And so you have to wonder, can I mitigate these 2 things simultaneously? And that allows you to put them in parallel. Okay, here's a little picture of an offshore gas production platform like the ones at Petronas, and this one takes 1,190 days, probably elapsed days, I guess, and costs $1.7 billion, and that's about right. And it has fabrication and drilling and installation, hookup and commissioning, engineering, and all that. Okay, so now let's assign these risks. And here's these risks. I've added 110 and 111. This is the 110 one is the project team may not be adequate for the complex tasks. Now you can look at the project team for any particular project that you're on, and you can say, hey, this is a really strong project team. Or you can say, oh my God, there are too many TBDs. There, the manning table is blank. We don't know how to do this. This is about the system that the owner team is using to deliver the project successfully to the market. And if the project team is not very good, it can be a real problem for everything. It can be a background problem, but it can be a real problem for everything. And again, some people in AACE think that systemic risks have to be 100% likely. I don't think that. I think that they have a 20% chance of happening with some impact, as I mentioned before, happening with some impact on the schedule. In this particular case, I've guessed that, but okay, it could happen. The impact is if they happen though, this particular thing with a bad project team, the best case is 110%, most likely is 120, and the worst case is 130. Let's see what kind of Monte Carlo simulation result I get for a somewhat more general case study. This is the one that I have. Again, I'm not talking about a project by a company that works on the 80th percentile. That is, they will give you a result that is 80% likely to happen with the risks as we know them and the schedule as we know it. And say, okay, anything above that is risk that we can't mitigate or we can't be bothered about it. Excuse me. This particular thing says, okay, with these items in the 1100 and something duration, this is going to add 358 days at the 80th percentile because you're using the cumulative distribution. There are two modes to this particular distribution. One is the one on the left that has most of the probability. One on the right at about April 1st, 2025, is from that systemic risk, a bimodal distribution. That's okay. I mean, there's nothing wrong with that. But this is an 80% company. They don't care about anything that is less than 20% likely to happen. So they don't really care about this because it's only 20% likely to happen. If it were 25 or 30%, they'd start caring a lot. But it's only 20% likely to happen. So it's right on the edge of their caring. Okay, now what I said was it's important to prioritize the risks. And so we want to prioritize the risks to get to mitigation. So here's a method I developed about 5 years ago, and the software manufacturers, Polaris, which was Booz Allen Hamilton, but that doesn't work anymore. And even for Booz Allen Hamilton, it doesn't work. And Saffron Risk, and they've automated this, and it works on multiple simulations, and it's trying to get information that management wants before they can decide whether to spend the money. So I'm doing multiple simulations. These are not iterations. These are simulations with a bunch of iterations. I tend to take the iterations back maybe to 1,000 or 2,000, whereas I have 10,000 for the overall total. Because even with with this method, even with only 8 risks, I'm going to have to do 36 simulations. And if I have to do 36 10,000 iteration simulations, I'm going to be able to go and see a movie and come back. So well, maybe that I'm using fast software. So I take all the risks that are in there, and I take risk number 1 out by zeroing its probability, and I run the simulation with that out, and I figured out what the P80 is, and it could be the P90 or P70, whatever your company is comfortable with. And I get that data, and then I put it back. I do a second iteration with risk number 2, offshore design firm. Get the 80th percentile with just that risk out, as if it were fully mitigated. I'm going to hesitate to say that because you can't really fully mitigate any of these risks. There will be residual risk, but that's the way this method works. And finally, I get down to risk number 8, and I've taken them out, and I take risk number 8 out, and I write down the P80 for this particular project. Turns out that the risk number 8, if it's taken out, I get the earliest P80, earlier than any of the other risks when they were taken out one at a time. Therefore, risk 8 is arguably the most important risk to mitigate. Now, again, I don't know whether its cost is going to be economical, but it is the one where you get the biggest bang. Maybe not the biggest bang for the buck. This may be a $5 million risk, and risk number 4, which is the second risk that would be taken out, is only $50,000. So I don't know about that, but notice that I'm giving management a piece of information that they can use, which is how likely are we to how much time am I saving? You want $5 million? Do I save 5 days or 5 hours or 50 days? What do I save? This is the way to handle that. Okay, and then you go on to the next one, but you take out you've already taken care of risk 8, so it no longer appears, and now you got 7 iterations to go to get the second risk, which happens to be risk number 2 in this particular risk. So you're doing it. You're getting management something that they can understand how it's done, and oh, by the way, it gives them management actionable information. And this is the histogram. This is the tornado diagram. Usually, tornado diagrams say what the correlation is between the activity duration and the finish milestone. or if you're using risk, what's the correlation between the risk and the finished milestone? Well, so somebody says to management, if you give me $5 million, I'm going to reduce the correlation of that with the final milestone from 70% down to 20%. And management is going to say, okay, how much of that is well, I was going to say American money. How much of it is in Australian dollars for that 5 million Australian dollar investment that I make? Well, my methodology says how many days are saved, 158. If you take risk number 110, which is the complexity factor on the systemic risk, which means you better beef up your project team. And I've seen project teams that are very, very robust and are going to handle it just well. Okay, now the next thing I want to show you is a little bit of a different sort of thing. It is probabilistic branching, which you could do at level 4 and level 5. I guess you could do it at level 3 if you cared to. And this is the sort of the gestation period of a project up through initiation, formulation, and then finally implementation. And it's the final investment decision, FID, you see at implementation. That's where we typically practice all these things. But many of the most important decisions, the strategic decisions, are made much earlier, many months earlier than that, at initiation or during the formulation stage, where they're doing analysis of alternatives, and they know that those alternatives are risky. So what I want to do is to develop a little really simple risk model that will point to the risky area and say, okay, what are you going to do about that, and get the leaders of the organization involved in specifying what is the risk, how do you describe it, what are the parameters behind it, how important is it, so that they can understand how risk should be cranked into their own strategic decision. So this is just how do we plan a project with unfamiliar technology that's unfamiliar to us, where we have to develop what the technology needs to understand that we have to develop the science and engineering expertise to handle this new technology. A lot of people say, hey, we've got this $1 billion project. It would be a wonderful chance to use new technology. And somebody will say, well, there's this existing technology. Forget that. That's not exciting. We want to do something new. Okay. Oh, by the way, we do have competition, right? And our competitor is doing something of a similar nature. And I don't know what methodology they're going to use, but we don't want them to beat us to market. So schedule is important in addition to solving this technology issue. And so here's a picture of a probabilistic branch. And fundamentally what it says is, we explore new technology. How long will that take? If it takes 100 days in this case to explore that technology and to satisfy ourselves that we can go on to developing it using the new technology, that's great. On the other hand, we might meet some small problems, or we might meet some really serious problems. And the small problems will have a little bit of time, and the real serious problems will take a lot of time. And so that is the definition of our probabilistic branch. We either don't have any problems, or we got little problems, or we got big problems. And that tells me how long it is going to take between the finishing of the explore new technologies to design the product using that new technology, right? You can't design it using the new technology until you advance to these engineering or scientific. And here's a logic diagram of the explore new technology branch, and there's some risks associated with that. Nothing found. Well, the sponsor of this particular project says, hey, 70% likely I'm in good shape. I just, nothing's going to be found. We're going to go right to design the project using the new technology. There may be some minor issues. That'll only be 20% likely. And there's 10% chance we'll run into major issues. Okay, well, what do those mean? Well, if no issues are found, then there's no delay. If minor issues are found, let's say it takes 20 days to delay. If major issues are found, it takes 80 days. Because we say if major issues are found, we'll assign 6 engineers working 8 hours a day, so 3,840 engineering hours, and that'll do it. Now, 80 days is a lot of time, and we really don't want to spend that, but it's only 10% likely, so they don't care. So we got a Monte Carlo simulation, and there it is. The left-hand mode shows that no problems are found. It's arranged because there's some risks behind it, but no problems are found. And there was there was also risk in the new design product using the new technology. There's some uncertainty and risk in that one as well. And any one of the three branches has to go through that as well. So, okay, and so here it is, and the 70% chance of nothing happening, and the 20% chance of minor things happening for 20 days. That's all in the left-hand mode. And then the 10% chance of of a lot of problems, according to the sponsor of the project, is over here on the right-hand side, a little secondary mode on the right-hand side. Notice that they're an 80% company, so they surely don't care about something that's only 10%. And you get the same thing for costs. Okay, now somebody said, let's take somebody else at the high level figures out that we're in need of something, and they say, yeah, I don't think that guy's right. It's 70% likely for having major issues to be found, and 10% likely for no issues to be found. In other words, flipping the two no issues, major issues, flipping the 70%. 70% now we have to really look at what happens if the major issues are found. We decided we'll in that case we'll hire 14 new engineers, and we will hire 14 new engineers, and it'll only take 24 days, still the same 3,840 hours. And this is the schedule duration. This is the cost duration, and the cost is not much because there's still 3,840 engineering hours, but it's 70% likely to happen. So all of a sudden, this is a big deal. I'm not saying that one of these people, the experienced leader, is pessimistic and he's right, or the project sponsor is wrong or right because he knows the project and he thinks that nothing will happen. But what I'm saying is that we get the discussion going at the right level, at a high enough level in the strategy to make it important. And again, here's the deal. The schedule is about the same because with the 70% chance of having major risks, we hired some more engineers, but the cost is remarkable. And so if this is a 400, if this is a $3 billion project, this has added $1.6 billion to the cost. It's a lot of money. Okay, now I want to go to level 5. Level 5 is the maximum for me and for the project software at this point that we can talk about anyway in this model. You can see in the blue the project schedule risk and time risk. That's what we've just been talking about. Oh, sorry. In the right-hand side, the tan stuff is cost risk, and that has two components: time-independent costs, which are things like raw materials like steel and concrete and equipment to be installed, and then there's time-dependent costs. Those are the labor costs, the overhead costs, the cost of equipment, like how long do you have the scaffolding up? If it's an extra 6 months, it's going to cost you an extra 6 months. Or how long do the drill rigs help? If it takes them 35 days instead of 25 days to drill a hole in the ocean floor, they're going to charge you for that. Now the burn rate may be different because of worldwide conditions like labor conditions and steel prices, and the time independent cost. That's the only thing that makes those rangy. But the thing in the blue circle is time dependent costs are determined by the interaction of time, which is a schedule uncertainty, and the labor type resources, which have a burn rate, and they're going by the time allotted, and the longer they take, the more they're going to cost. So ICSRA, I'm going to have you say after me, ICSRA, ICSRA, Integrated Cost Schedule Risk Analysis. You got to learn that before you go to bed tonight. ICSRA recognizes that activity durations and costs are related when labor type resources are present, and they are. So here's what happens: time dependent labor. If it goes, and it could be labor on hammocks as well as on activities. Now, by the way, a lot of people don't like to put resources onto schedules because they think that's too hard. The only distinction we need to make is between labor type resources and equipment type resources, material type resources. They can be a lot of different things, but if they're charged according to the number of days they're used, that's labor type, and and the things that are installed, that's not according to the time. It's according to the world prices of raw materials, for instance. A lot of people don't like to use resources, so these software packages have the opportunity to put the costs into a an Excel spreadsheet and enter that into the software. But you still have to parse those out into how they affect various activities in the schedule. So I'm not sure that it helps much, but it is possible. Here's something that you can only do when you integrate cost and schedule, and this is the scatter diagram of cost and schedule. The x-axis on the x-axis with the dates is the finish date of the schedule. It can be whatever target you want, and the vertical distance is the cost, in this case, total cost. And each of these dots represents one of the 10,000 iteration results for time and cost. So there should be 10,000 of them. I don't know if they. I think Saffron maybe doesn't plot more than 1,000 of them, but I think there should be 10,000. Now notice the left hand way down at the bottom, in the green, is a deterministic plan. That's only 1% likely to happen with success on cost and schedule if you're using the deterministic plan. We're using the term joint confidence level, or JCL, which the United States National Aeronautics and Space Administration coined for this duration. The crosshairs are now at the P80 for cost and the P80 for time. But if you notice in the lower left-hand corner of this scatter diagram, it says that only 74% of the dots are in the left-hand corner, or in the left-hand quadrant. In other words, you may think you got 80% cost and 80% schedule, but when you look at the two of them together, there are a lot of costs that are not finished by the time you got 80% schedule, and vice versa. So you have to add time and you have to add money to get the to make it possible to claim the finish date of the two things together, of the time and cost. And the red dots, the envelope of the red dots on the lower, all of those are different combination of cost and schedule that will make 80% for the two of them. And if you move it up there, you see that you have added 1 or 2.5 months to the finish date and 150 million to the P80 values, but you've brought the probability of finishing cost and schedule up to 80%. Now notice that this is the scatter diagram is slanted from lower left to upper right, indicating that the longer things are, the more they cost. This is for a project that has a fair amount of time dependent resources, and I've got one right now that's 70% labor and 30% equipment, but they say that's the right thing, so that should be very highly correlated if I were to do this. Okay, now here's the problem. There's let's call this scatter diagram a three-dimensional ridge of probabilities, like a topographical map, and the highest point in that ridge at any point is where the dots are most congregated. Okay, so what you want to know is what is the most likely one of all those dots on the frontier of the red. Every one of those dots gives you an 80% cost and schedule joint confidence level. Now, it turns out that you want the most likely. So here's what we do with the most likely. A friend of mine and I, Sam Steinman, put a paper out to AACE that was actually published in Cost Engineering as well, on how do you represent that range as a three-dimensional object. And here we've got the range of three-dimensional object where we cut the time and the cost axes by 50 into 50 elements individually, and then toted up the strikes in 10,000 iterations in each of those cells. Okay, so now this is another one. The pane there is I didn't show you that, is the regression line that Saffron has kindly given us. If the thing is fairly highly correlated, 60, 70 or 80% or above, that regression line is a good proxy for the most likely. Okay, so we're going to go here, And then we would like to find out what is the most likely P80 number that we have, because we can't choose it. It happens to us. We want to tell Congress or the Parliament what's the number. Okay, we're using a kernel density estimation, which is a non-parametric way of estimating probability density function of a random variable. And Sam is the guy who knows about this. Let me just show you what has. Oh, well, if we do that, I had something that had had some animation here, but that seems to have gone away. Okay, so fundamentally, if you drop the red necklace down onto that shape, the place where it in a vertical way, the place where it first hits the shape is the most likely joint confidence level 80, or in this case JCL 70, and that's the way to look at it. Anyway, so we now know how to pick the most likely JCL point as well. Okay, so everything we said, we've talked about that. I'm out of time, I think. Input data for the cost represents effective cost and schedule, and if it's not resource loaded, you would probably ignore something like 30, 40% or even more of the cost contingency reserve if you don't recognize the cost implication for schedule, which you can do at level 5 because you resource loaded or in some way loaded the cost onto the schedule. Then you're going to be looking at cost risk, but ignoring the schedule impact. And as I say, that often allows you to ignore something like 30 or 40% of the cost contingency reserve that is going to be needed. So you better remember that schedule drives cost in these things, and we have ways of showing it. Okay, and NASA has done better at meeting their goals with Congress after they use the JCL method. They're not better project managers, but they're better prognosticators because they're telling Congress better, more reasonable, more achievable numbers by looking at the joint confidence level instead of at the P80 or P80 cost or P80 schedule. Okay, so larger, more complex projects deserve level 5. XRA can be applied to the project as soon as there are estimates and schedule, and we prioritize risks so that they can be mitigated. That's where the benefit can be realized, where they can be mitigated. Okay.
Okay. Thank you, David. And I'm sorry for the time limitation that we're having, but we still have a few minutes. I'd like to address a couple of questions. Bahi is asking, David, how can you perform an integrated cost schedule risk analysis during the early stages of the project when there is no project schedule or estimate available?
No, you can't do that, and I think you can make a sort of a structure of something that is very you just don't have the wherewithal to do it. So I would not promise to do that. You could make a model that you might use to sort of tell people what it's like, but it won't be accurate, and you just shouldn't expect to.
Yeah. Also, Bahi's making another question. Can the parametric risk analysis integrate with the integrated cost risk analysis? If yes, how? If not, why not?
We have a lot of we have some recommended practices and some papers that are talking about hybrid methods of integrating the parametric approach that John Holman, for instance, is talking about with the Monte Carlo simulation. Although I think they're using expected value Monte Carlo, not the whole Monte Carlo that we're talking about. Colin Cropley is the guy that many of you may know who is doing this, putting his oar in. He's got a paper that is being he's got a recommended practice that I'm still working on to show how he does it. And when that comes out, you can see what gives. What it's like. It's pretty complicated actually, because you have to worry about not double counting some of the uncertainty.
Yeah. So another question from Sadat is, well, he's concerned that most of the software used to Monte Carlo simulation are very costly. Is there any way to do that without using this software that are not very expensive?
I think the software. I don't know. I'm not. I don't sell software. I think the software is $5,000-6,000. Primavera Oracle still selling Primavera Risk Analysis. Yeah, I don't know whether they will do it anymore, but because I don't think they support it. But they used to sell it for $9,000 or $12,000, depending upon what country you're in, for some reason. But yeah, it's a strange thing. But I would not recommend doing schedule in Excel. You could use Crystal Ball or At Risk in Excel, but then you'd have to have a structure of a schedule, and I really do not recommend scheduling in Excel. It's just a cause of disaster. And on the other hand, you can't do a cost that you could do a cost estimate in Excel, but how do you represent the scheduling component? So no, I don't. It's $5,000 or $6,000. I don't know how much it is, but I think that's the sort of cost range it is. And unfortunately, I don't see any alternative to that. Certainly, don't develop it yourself. It'll cost you or your company many tens of thousands of dollars more than buying it off the shelf from a bunch of people who have debugged it and all that for you.
Okay, thank you, David. One more question from Bahi. Do you use cost and duration ranging together with the risk driver method?
No, I don't think so. I mean, let's put it this way. If you're using the risk driver method, you do have to have background uncertainty estimated separately, and it's 100% likely. So that looks like duration ranging. So that part of it is just like what Michael Curran wrote 20 years ago about that, the one that is being retired. So uncertainty is essentially activity ranging, not knowing what the causes are, because uncertainty is background, and there are multiple things happening, but fundamentally it's background noise and all that. But it's 100% likely, and it's applied directly to activities. The beauty of level 4 and level 5 is that you can start with and specify risks, and you can talk about risks. And that's good because you can also mitigate risks, but you can't mitigate a duration. I mean, if somebody says, hey, this is a 50-day activity, it could be as low as 40 days and as high as 80 days, and it's most likely to be 55 days. Okay, so how do I deal with that? If I don't know what's causing it, I don't know what to do in order to make it narrow.
Mm-hmm.
So no, you can't do that. But uncertainty is like duration ranging because it's 100% likely.
Yeah, great. Okay, one last question from Mauricio. Does Safran support conditional branching?
Excuse me? Does what?
Does Safran, the software,
Conditional
support?
branching. How did you know to ask that question? That's a good question. Yes, Safran does promote conditional branching. And one of my associates, Keith Hernbacher, and I have written a paper that we gave to the expo, the UK expo that's virtual this year, on conditional branching and probabilistic branching. I just gave you the probabilistic part here, but yes, we can do conditional branching there. It's using scripting. The next version of Safran that comes out, which I don't know how long it'll be, but it's imminent, will have probabilistic branching as a user feature. But still, conditional branching will be, you'll have to script it. Now, look, I'm no programmer, but the scripting is very easy. And in fact, I've been playing around with it to get a pretty good representation of that for another purpose. But yes, conditional branching. I don't know of any. The only other program that I know of that has conditional branching is Risky Project out of Calgary, Alberta, Canada. And they used to have conditional branching in PertMaster, but I never could get it to work. There was conditional branching 20 years ago in a little package called Risk Plus, Risk with a plus sign at the end. And that was a little thing that used, that was an add-in to Microsoft Project, so it using Visual Basic. And they did conditional branching, and they gave you a template for how to write the script. But that doesn't exist anymore because they don't. Deltek bought it and didn't support it, and it hasn't been updated because Microsoft Project is going on and it now no longer works. but I think that Saffron does have it, and I, on the other hand, I don't know of any documentation about how to use it. And we are developing a new 3-day course in Saffron keystrokes, and that'll be part of our course, but that's not ready yet, not quite ready yet.
Right. Thank you, David. Thank you very much for your detailed presentation. I know I have a few more questions, but we can maybe address them after I finish the recording. So I'm going to stop the recording.
Happy to wait here.
Yeah, and then anyone can unmute themselves and keep chatting. I'm just both in this meeting right now. Thank you, everyone, for joining the 10th technical meeting.